Welcome back. We're going to do another application problem. In this one, we're going to do a tide, representing the tide. Fred's favorite fishing spot requires him to drive to a place that's only accessible by boat when the tide is high enough. Fred's boat requires water depth of 3 feet to safely pass. At low tide, there's only 1 foot of water at this particular place. At high tide, there is 7 feet of water. High tides occur about 12 hours apart. We're going to find a model that represents the depth of the water at that location T hours after the last high tide. Then we're going to find the time Fred will be able to pass to access his favorite spot and the time he will have to get back to the pass so he won't have to wait until the tide comes back in. So the first trick is to find a model. Let's draw a diagram, show what happens here. Let's say here is the bottom where Fred has to pass, and at low tide the water depth is 1 foot. At high tide the water depth is 7 feet, and Fred needs 3 feet of water to pass. So this is basically what we're looking for. The water depth goes from 1 to 7 feet. So we're going to use a function. We're going to start this. We're looking for hours after high tide, so we're going to start when the tide's at its highest. The tide's going to be in, it's going to go out, and then it's going to come back in again, and we're told that this happens every 12 hours, so that means the cycle will start to repeat again after 12 hours. That means our period is going to be 12. That means that 2 pi over b has to equal 12. So we multiply both sides by b and divide both sides by 12. We get 2 pi over 12 is equal to b, or pi over 6 is equal to b. This looks a lot like a cosine curve because it starts at its highest point, ends at its highest point. So we're going to make our function f of t equals something times cosine. B is going to be pi over 6. We don't have to shift it because we're starting at the highest point. Don't have to shift it right or left. So now we need to figure out the amplitude. The amplitude is the height of the water above the bottom. 7 is the max. 1 is the min. So we do 7 minus 1 equals 6, and 6 divided by 2. 3 is our amplitude. So 3 goes up front, and now we need to figure out how to shift it, because what we have here, this curve, if we graph this curve, what we'll see if we graph this, let's set the window from 0 to 12, so we see one complete cycle. X min 0, X max 12, so we'll see one complete cycle. That's our period. We'll do Y min, let's go negative 5 to 5. So this is the curve where the bottom of it, the y value is negative 3, the top of it, the value, y value is 3. We need the top to go to 7, and we need the bottom to go to 1, so we need to shift this up 4 units. And now, if we shift this up 4 units, let's reset our window, our y's, because let's set our min at 0 and our max at 8. 1 foot below and 1 foot above what we want to see. And then we'll go to y equals, and we will add the 4 to shift it up 4 units. And then we should see, when we graph it, at high tide 7 feet, and at low tide 1 foot. And that models the tide. So this is the function that satisfies that. Now we're supposed to find how long after the tide goes out will Fred be able to access this. if we want to do that, we can look at this and say another y equals, we need the water to be 3 feet deep, so we're going to graph it. And what we see is Fred at high tide. Fred would have until whatever time this is, the time they're represented on the t-axis, x-axis. And then Fred, these are the hours that Fred could not get packed through. So Fred would have to get to the place before this, and then he would have to it would be this long before he would get in. Let's just see what we got. We're going to do second trace intersect. If I want to find this value first, I'm going to move as close as I can to it on that first curve, and then second curve, and then tell it to guess. And we usually find the closest one. So this tells me 3.65 hours after high tide, Fred will no longer be able to access it. We're going to change this question a little bit and say just what periods of time will Fred not be able to get through the pass. So from 3.65 hours, 649, let's do 3 decimals, that's what I've always told you. Now we need to find the next time. So we're going to do second trace intersect again. Oops. Did second trace intersect. If we want this other intersection, we're going to move our cursor using the left and right arrow keys closer to the intersection we're looking for. Second curve, tell it to guess. And this is going to be at 8.35 hours. 351 if we round it up. So that means when the tide, after high tide, he would have 3.649 hours to get to the place before he could no longer pass. And then if he got in, he would have to wait until 8.351 hours after the high tide to be able to cross back out. So that's what we were looking for on that. But the key is setting up this model so that we can predict the tide, how high the water is at whatever time after the high tide.